Hello, everybody. Welcome back to Scientific Mathematica. If you can't tell already, this is Ellen, and today's video is just going to be an expansion on everything we learned in the last video. I believe it was genetics and Punnet squares, and I'm sure you all know what Punnet squares are. They're those tables that we use to determine the probability of an offspring having a certain trait. And so on the screen you see two words here, monohybrid and dihybrid. And they're really similar words. They have the same hybrid, but their roots, I think they're roots. Prefix? They're different. See? Whoops. The root mono typically means one. You probably know that. It means one. Di, however, means two. And so a monohybrid looks like the cross we did last week. It looks something like that. And it's monohybrid. One, because we determine the trait with one allele. And these are typically blood type, eye color, that type of stuff. Dihybrid, on the other hand, typically looks like this. I'm going to have to draw it smaller because I don't have space. Okay, it's going crazy. But they look something like that. It's actually 4 times the size. And di meaning 2, meaning that 2 alleles determine the trait. That means every factor is reliant on something else. And so we have that. They're both types of Punnett squares. Monohybrid being the basic, dihybrid next level. Trihybrid and tetrahybrid crosses actually exist, but they're quite hard, so maybe I'll teach. But anyway, let's get started. I'm going to recap on monohybrid crosses, if you forgot, because it's quite important to know. So remember, monohybrid often looks like this, like a window you draw when you're 6 years old. And for the organism, let's use pea plants, because those were the first things ever experimented with. We're going to say G, capital G, the dominant trait means the pea is green, and lowercase g, the recessive trait, meaning the pea is yellow. Now, I don't know if that's true, but in this case, it is for now. And so, let's make up some random genotype for parent A. I decide they'll be heterozygous. That's parent A. That means they're green because, well, according to the law of dominance, it always masks the recessive trait, so the dominant trait always shows. So this plant is going to be green. The next one, parent B, let's see. Let's also make it heterozygous. The second parent is also green because, again, the law of dominance states that a dominant, if it has a dominant allele, it is always expressed. And so, to solve this cross, we do what we usually do, and we put one allele over each side. And again, simple math. It's basically Battleship. This row and that column come here with 2 capital G's. And then you just do the same. You carry this over and this down, meaning you have that. And we're just going to do that with the remainder of the boxes. Excuse my handwriting. And so we have that. And with this information, we can determine that 3 out of 4 times, here, here, and here, the pea plant is going to be green. But this one, this little box right here, we know that 1 out of 4 times, or 25% of the time, the pea plant is going to be yellow. And so that's what a monohybrid cross does. But let's go into dihybrids. It's much more complicated, but the concept's the same. So we're gonna draw a much bigger cross here. That might have been too big. It's not gonna be a square, but that's okay. It's still called the Punnet square. You might notice now there's 4 rows and columns. You might be like, oh, then where do you put the letters? If you were to put one letter on each one and cross it, you'd still end up with the typical 2 alleles. And you need more than that. So it's dihybrid because we usually cross traits that contain multiple alleles. For example, let's take the pea plant again. Okay? And so this time we have a lot of different options. Capital G being green again. Lowercase g being yellow. We're going to have capital R meaning round. And lowercase r meaning, well, not so round, wrinkled. And so keep in mind, the capital letters are always the dominant traits, meaning that if you were to have a capital G and a lowercase g, the capital G, which is green, would always be expressed. And we're going to have 2 parents. This time they're going to have multiple alleles. We'll give parent 1 they're green and round. Okay? Parent 2 is going to be yellow and round. And so what we do now is insanely complicated. Why is there no eraser? Oh well. Anyway, let's get rid of that. And so we now know the parents look something like this. X means, well, we're pairing them, we're combining them. We have that. But we still need 2 letters above and next to every row and column, because to cross it, you'll end up with offspring that look like their parents. They have multiple alleles. And so we do this thing called FOIL. If you have, I'm sure, in elementary school, if you finished elementary school, you probably have heard of FOIL, the FOIL method, or middle school actually, it's an algebra topic. And what we do is we basically list all combinations possible of the parent. So for example, we have parent 1 or parent A and FOIL. I forgot to tell you what that means. FOIL typically means, you can't see it right now, but it means first, outer, inner, last. It's an acronym. We call it foiling. And so basically what we do is first, we're just going to pretend this is separate. There's a line right here, okay? So first, let's delete that line actually. First would be these 2, because, whoops. Sorry, let's do that again. we take parent 1, and we're going to FOIL it. FOIL typically means first, outer, inner, and last. It's an acronym. Now, this is usually used in math when you are multiplying binomials, and you might have not learned that, but you're learning it now. Basically, what you're doing is you're finding all possible combinations of these alleles, and then you cross those. So how it works is we go first. First tends to be these two. Right here. G, capital G, and capital R. So we write that right here. And then we go outer, which is the outside two. So we go capital G and lowercase r. And inner, which is these two. Can't draw. Which is lowercase g. For this one, we're just going to have G always go first. And uppercase R. And the last one is last. It's like the first, but the last two. So we have this one and that one. I should have used a different color. But anyway, you have those two, which is a lowercase g and a lowercase r. And what we're going to do is the exact same for every parent. For the sake of time, I'm going to do it for you. And I'm also going to type it out because it can't fit. You have GR. Here, you're going to have first, that's first. Outer is GR. Inner, lowercase g, uppercase r. And last, lowercase g, lowercase r. So we're going to cross them like usual. Remember, battleship? And so you're going to take what's here and what's here. And you're going to put the G's first because they go first. And so, you know what, let's type it. Here, we're going to have G, G, R, R. It's going to look something like that. Okay. And so that's our first square. And we're going to do all the other squares exactly the same. Until we're done with the entire thing. So I'm just going to do it for you. Because I think you get the point. Anyway. We're going to go here. We're going to do the exact same thing. Bring down the column. Across with the row. If you don't get it, feel free to rewind. I'll do a recap once we're done with this. So once again, same thing. Hope I'm not making any mistakes. And one more time. So you're going to notice most of them look different. And I guess it's kind of a pain in the butt. But we're going to have to deal with it. So right now, let me get rid of that. Okay, and so now we have that. And the hardest part of this is actually not the crossing. It's determining the percentage. So you might notice how many of them have the same ones. So I'm gonna put a little green dot if they're the same. So right here, that's the first one. And just look around and see if any of them have the exact same one. Select that one. And we're gonna keep going. And I think that's the only one. So we have 2 of those. Next one I'm gonna do in blue. And we're gonna do this combination of letters. So capital G, lowercase g, capital R, lowercase r, both heterozygous. So this one here, this one here, this one here, and that's about it. And so there's 4 of them. We do the exact same thing with yellow for the next one. This is the easiest way to find out how many of each there are. So we're going to go with this one. Both homozygous, but G is recessive, R is dominant. And I think that happens to be, there's 2. One right there. Do that again with orange, or just going to keep repeating until every single box is filled. So this combination of letters, let's see if there's any more. There's one right here. And there's one right here. And if I'm correct, that's about it. And anyway, we'll move on to red. And we're going to do this one. Capital G, lowercase g, and both a double lowercase r. So there's one right here. Oh wait, I missed one of the oranges. I'm sorry. There we go. And I think those 2 are the only reds. Next one, we're going to go with purple. We have all lowercase. And there's 2. And so this way it's easier to count. And we count it this way. So we're going to go, you list them out. We're going to type it out. And so we're going to go with G, G, R, R. Let's put that down. And this genotype means it's green and it's round. And there are 2 of those. Exact same thing with the next one, G, G. This one also means it's green and round. But there's 4 of them. Next one, this is yellow and round. And there's a purpose for doing this, you'll see. There's 2. Next one, we marked it in orange. It means yellow and round. And there are 4 of them. Keep going with the next row. Oh, wait, that's already been marked. Do red. That means it's green and it's wrinkled. There are 2 of them. Next one marked in purple. There are 2. Whoops. It's yellow and it's wrinkled. And there are 2 of them. And if you add them up, it all should add up to 16, seeing there are 16 squares. So 2 plus 4, 8, 6 plus 2, 8 plus 4, 12 plus 2, 14 plus 2, 16. So that's all right. But we're going to take a look right here at this little section right here, okay? And so you might notice they're all different. Those are the different genotypes because they're the genetic makeup, if you remember. And you might say, okay, there's 6 different genotypes. Most of them have different, numbers. And what we like to do for dihybrid is type the ratio. And so we just go 2 to 4 to 2 to 4. Or actually, no, we like to put it in order of largest to smallest. So let's do it that way. And so that ends up being our genotypic ratio. And most test questions, most worksheet questions usually ask for the genotypic or the phenotypic ratio. When the genotypic ratio comes up, you usually have that. you end up with that. Let's put it in a different color. And then we're going to do the exact same thing, but this time the phenotypic ratio. And now you might be wondering, but what's the difference? Now, remember that phenotype is the physical traits. So, and these are the physical traits. From first glance, you easily notice that some of them are the same. Like there's 2 green and rounds, 2 yellow and rounds, 1 green and wrinkled, and 1 yellow and wrinkled. Meaning that now these 2 mean the exact same thing, although they have different letters. These 2 also mean the exact same thing. And so you see the phenotypic ratio is different of that because of that. So we're going to type it down here. Phenotypic. I spelled that wrong. And we have 6 of them are green and round. So we type that. 6 of them are yellow and round. And we have 2 green and wrinkled and 2 green and wrinkled. Let's delete those spaces. And so we end up with our answer right here. That's the genotypic ratio and the phenotypic ratio. It's quite confusing, but after a little bit of practice, you get it. I think we should do another one maybe. But if you need a little help, feel free to email me. I'll link my email in the description. And so that is how you do a dihybrid cross. And we're going to recap all this. Let's delete everything. It still bothers me there's no eraser here. Anyway, that's the end of dihybrids. So, recap. Monohybrid cross. You all know what that is. Mono means 1, meaning 1 allele. Cross usually has 4 squares and looks something like this. Next one. Dihybrid cross. It's a monohybrid, much more complicated and much harder. And they look something like that. Without all the breaks. I don't know what's going on. Anyway, that's what a dihybrid cross is. And remember, it's easier to remember it this way. Phenotype starts with a PH. Is the physical traits. They start with the same letters. Oh, whoops. Phenotype is physical, and genotype is genetic. Remember that, okay? And the ratios are often different because while the genotypes may be different, it's always the dominant trait that shows at the end, meaning some of the different genotypes don't show physically. And so you usually end up with a more varied ratio of genotype. And so we're going to do one last example with the dihybrid cross because, not going to lie, it's quite hard. If you get it, feel free to just follow along and pause before you solve it if you need a little more help. I'm going to explain it. So we're going to do, let's not do pea plants again. We're going to do cats. And I'm completely making this up, so don't go tell me I'm lying how capital S means striped and stuff, okay? And so here's our key in this case. Capital S. Let's make that slightly bigger. Capital S. Whoops, sorry about that. Capital S means striped. We're going to have lowercase s. Actually, let's not use S. It's too confusing of a letter. Y means striped. Spotted. And we're going to have B meaning black, lowercase b meaning white. So, two different alleles here. That's our key. And we're going to have two parents. Let's make them both heterozygous because I want to show you something. The thing about heterozygous is it's a really common thing. Like a test question may ask in words. Most of them actually ask in words. They'll say two parent You know what? That doesn't make sense. Just two parent cats are heterozygous for both traits. By this sentence, you can assume that they have one dominant allele and one recessive allele. And if you put it together, you end up with this following genotype. And anyway, let's make that smaller. Too small. Anyway, we have that. And now, as usual, we are going to draw a dihybrid cross. Too close. Please ignore my 7-year-old brother screaming in the background. The issues of having a homemade stylus. Okay, I'm sorry about that. Anyway, we have a dihybrid, empty cross. And remember, foil, F-O-I-L, first, outer, inner, last. Repeat it like a mantra until you remember it. And so we have that here, and we're going to cross the first one. So first is these two. We're going to type it out. We're going to type it out. I'm sorry. Y, capital Y and B. Second, let's do another random color. Outer. Outer. We'll do it in red. Outer. So, capital Y, lowercase b, inner. Inner is these two. And last being these two. Okay? And so we're going to write that out on top. To be honest, it doesn't really matter where you put the parents, but I prefer putting parent A on top. That came out wrong. But anyway, we have that. And I want you to do the second one yourself. Pause it here if you need a little time. And I'm going to do it. So foil. I'm not going to write it out this time. First, capital Y, capital B. Actually, I don't know why I said that. They're the exact same thing. Think about having two identical parents. Okay. But I wanted you to foil yourself. Even if it's the same, just do it again anyway. The thing about heterozygous is people expect you to memorize the ratios because it's the same every time if both parents are heterozygous. And I'll show you the ratio later, and I expect you to memorize it. If you don't, well, you can always make an entire dihybrid just to find it. And so we're going to cross them now. Remember, battleship, rows, columns. First one looks like that. Whoa, what is happening? Sorry. Second one looks like that. Third row. Remember, we always put the capital letter first. I'm not sure if I told you that yet, but we always do that because, well, it's easier that way. And I want you to do the second row by yourself. Pause the video right now if you don't want to see it. If you want to do it along with me, feel free. So, second one. I hope I'm not making any mistakes. Next one. I actually want you guys to fill out this chart yourself. So I really suggest pausing it before I reveal the answer because, well, you learn more that way. But you can always just watch me do it if you want, if anyone's even watching this. Anyway, we have a filled out dihybrid cross. And now we're going to find the ratios. I'm gonna quote unquote erase these markings. Oh, this is a pain in the butt. That's not gonna erase. Okay, so we have that. Move that up here. Okay, and now we're gonna write it out using a bigger font. The answer, most of the time, they'll be asking, maybe they'll be like, oh, how many how many cats are black striped? And you'll give them the answer. Or how many cats or kittens have the genotype, blah, blah, blah. But most common, they'll ask for a ratio. And so we're going to do the exact same thing we did earlier. And we're going to dot all of them with different colors because that's how we do it. We're going to start with red this time. Follow the rainbow because why not? This one. Put a red dot there. There's none with the same one. So we're going to go on to the next color. Orange. This one. There's one here with the same one. Why won't this work? Okay. And, ooh, there's one right here too. Oh my god. I'm sorry. Let's go around and I believe that's it. There's only 3. Okay. Next one. We'll do yellow because rainbow order. Hooray. We'll do this one. Heterozygous and homozygous dominant for the color. I'm sorry about this. Not the best teacher. Whoop. There's one right there. Is there another one? Yes, there is. I actually want you to do this yourself, like I said earlier. I don't need you just copying my answers, because that way you're not going to learn anything. So please, try it yourself. Anyway, let's keep going with green. The next one we have is this one. 2 capital Y's and 2 lowercase b's. And is that the only one? I think so. Yeah. So there's one. Blue. This one has the same genotype as its parents. Why won't it draw? Okay, I'm sorry. And I believe that's the only one. Please excuse the screaming in the background. Oh, wait, is there one more? No. I think I forgot a yellow one. You can scream at me in the comments below. I'm quite blind. Oh, wait. I'm so confused. Oh my, I did it wrong, didn't I? I'm sorry for the confusion. And so we're going to go on to yellow. I'm going to dot this one. And I believe that's the only one. Okay, we're going to go on to green. 2 capital Y's, 2 lowercase b's. And I think that's also the only one. Wow, a lot of solos here. And then blue, the next one. I like to go in order. You can go whatever order you want. There should be a couple more for this one. Yep. Oh wait, I forgot a yellow. Okay, sorry. We're going to blue. So we have one right here. And one right here. Okay. And let's see what else. Next color, purple. I'm kind of running out of colors. Oh boy. We're going to have this one dotted in purple. And there's one more right here. Excuse the yelling in the background. This won't draw. Oh my. Okay. Next one, we'll go black. So when you have pencil, you can just draw shapes because it's easier than switching colors. There's only one of those. And so I'm going to go back to red, but this time it's going to be a circle. Oh, geez. I'm sorry. And then we're going to draw a huge dot circle for that. And then the last one, there's only one of. So let's go orange. And we're just going to... Huge dot. Okay. So we're done with that. There's background noise. I know. I'm sorry about that. But I can't exactly control what's going on in my house. Anyway, we have a lot of different genotypes this time. Let's make that slightly smaller. We have that, which means it's striped. And it's black. And there are... Did I use red again? I meant to use black for those. It's a little chaotic. I'm so sorry. Okay, so striped and black. We have exactly one of those. Next one, we have that genotype. We have 2, 3. 2, 3. Oh my god. Striped and black. 3. Am I right? Yeah, I hope. Okay. So next one we have that genotype. There are 2 yellow dots. striped, also black. Am I spelling striped wrong? Yes, I am. Striped and black. There's 2 of those. And then the next genotype, it's still striped and blacked. Wait, no, I already done that. Okay, here we go. It's the next one. Green. It's striped, but this time it's white. Got a new one here. This one. Next one. There are 3 blue dots. It's striped, also black. There are 3. You see, the dominant tends to be more likely because it masks all recessive traits. And the next one is, that it's striped and white. Wait. Yeah. Have I already done that? Nope. And there is 1 of that. Then we went to black. Why did I mark 2? Chaos here. Come on, let me fix that. There's 2 of those. That one should be purple. Okay. Sorry about that. There's 2 of those. And then we have black. It's this one. There's only 1 of those, I hope. Sorry for the insane amount of mistakes I'm making. And the very annoying background noise of my brother trying to play William Tell Overture on his quarter-sized violin. Oh, here we have a first spotted one. Yay! Spotted. It's also black. And there's 1. Next one. It's white, and oh wait, it's spotted and black. And there are 2. Last one, all recessive. One that is 16. That means it's very unlikely that there would not be a spotted white. And there's 1 of those. And so now we have this huge list of genotypes. And we're going to focus solely on the letters. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9 genotypes. I'm going to ask you to memorize this. Well, this ratio is kind of hard to memorize. It goes 3, 3, 3. Oh, it's pretty easy. 2, 2, 2, 1, 1. Wait, there's only 2 2s, right? No, there's 3. 1, 1. There's 1 more. 1. So we have that. That's our genotypic ratio. You have that here in purple. 3, 3, 3, 3 to 3 to 3 to 2 to 2 to 2 to 1 to 1 to 1 to 1. Those dots, the 2 dots, usually just mean to separate the numbers. I'm sure you know what they mean. I hope I got it right. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh my god, what did I do wrong? Oh, there's only 2 3s. Oh boy. Okay, so there's the official ratio, not that. To be honest, just feel free to screenshot everything. That way you don't need to take notes or any of that time-consuming stuff. Anyway, that's the official genotypic ratio we have here. And we're going to go on phenotypic ratio. Now we're going to completely ignore the letters and focus on those, the words. So we're going to start with striped black. And that's going to be the first one, the second one, third, fifth, and that's it. We add up those numbers. You should get 9, I believe, if I'm not doing the math wrong. 1 plus 3 plus 2 plus 3 is 9. Yep. The next one, we're going to go and do striped white. There's actually 2 of those. And we have that as the 4th one and the 6th one. It's 1 plus 2, which is 3. And then we're going to go on to do the spotted black. You see I can't count, 6th, 4, 5, 7th, and 8th one are both spotted black. And if you add them, you get 3. And then the spotted white. There's only one of them. I've realized that this video is dragging out really long, so I'm going to end it right here. So, this is what you need to memorize. What is highlighted here? That is the genotypic and phenotypic ratio of 2 heterozygous parents crossed, and for both traits. And so the phenotypic ratio is easy, 9 to 3 to 3 to 1. It all adds up to 16, I'm sure. Yeah. So basically, that's how you solve dihybrid crosses. It's really complicated. Not really. Trihybrid is probably more complicated, but you don't need to know that. This is the typical stuff that will get you through maybe Science Olympiad, if you know what that is, and then biology class in high school? Middle school, at least. Anyway, thank you for watching. I hope you understood something out of everything I taught you. And remember, you're watching the Scientifica Mathematica, and I hope to see you next time. Aspiring young mathematicians and scientists, our goal here is to teach you to love science, to love math, because those two happen to be the most terrifying, most difficult, complicated subjects to learn. And so you shy away from them. You settle for English or history or something that you just have to memorize. But math and science, they're hard, but they're fascinating. They're half the jobs that exist today, and